Okay, so the haloform reaction. It's one of the most important topics in haloalkanes and haloarenes, and we're going to look at what that is. So essentially, in the haloform reaction, your reagents are fluorine, or you can't do fluorine, you can do iodine, or you can also do bromine. And along with that, you'll actually take a base. Now, this base can literally be anything. It can be NaOH, it can even be Na2CO3, which is something that we don't see a lot in inorganic. And then you can also have something like cesium hydroxide. Or to confuse you a little bit, they'll actually give you something like CaOCl2 twice, which is nothing but bleaching powder. But other than that, you can also have something like NaOCl. Now, how do you get this? When you take a look at this, you have NaOH plus X2, and then it undergoes a disproportionation reaction to give NaX plus NaOX, right? So this has a -1 charge, and this has a +1 charge, and this has 0 charge. So that's disproportionation. Now, when you have something like this, okay, it undergoes the iodoform test, okay? And what is the iodoform test? Well, when you have something like you have a carbonyl group, okay? And while I do use the word carbonyl group quite freely, we have to remember that here the word carbonyl group only indicates aldehydes and ketones, okay? So we can take aldehydes and ketones, right? So when you're taking aldehydes and ketones, that is specifically those that have this kind of a group, okay? So something like that. Or when you take an alcohol, which again, it has to have this kind of a group in it. Then they undergo the haloform test, the chloroform, iodoform, or bromoform test, okay? So, what happens when they undergo the chloroform test? Well, I'll just show you one step, and you can probably do it the rest of the way. I'm going to take an example like acetone. It's pretty simple, right? And so then I'm going to make it react with NaOH first, okay? Now what happens is, now this is an electron withdrawing group, right? So it withdraws a lot of electrons from my CH bond, and so this bond grows a bit weak, and so my hydrogens are actually active, and this OH, it reacts with one of the hydrogens and it goes out as water, right? And so I have something that looks a bit like this, okay? CH3, C double bond O, and that's a triple bond, sorry. And I also have CH2, but now it's a minus, right? And what I'm going to do is, when I dissociate my NaOCl, okay, dissociates a bit like this, okay? NaO minus and Cl plus. So this Cl plus, it comes and attacks here, and I get something like that. Okay, CH3, C double bond O, CH2, Cl. Now again, the NaOH attacks with my active hydrogen, and the cycle continues until I get something like this. Okay, CH3, C double bond O, CCl3. And now in this case, when I add an NaOH, this OH goes and attacks with the alpha carbon, and so I get something that looks a lot like this, okay? And this splits off, so I get CCl3 minus. This is carboxylic acid. It has an active hydrogen, so CH3, C double bond O, O minus, okay? My active hydrogen goes and joins with CCl3, so I get something like this, okay? I can better write it as CHCl3. This is my chloroform, and now one of my NAs goes and joins with this, and I get a sodium salt of carboxylic acid and my chloroform, okay? And so this is called as my chloroform test. So the main things that I'll be asked here are whether or not a particular molecule undergoes the iodoform test or chloroform test. Then you have to look for these two signs. If it has this kind of a group, it will undergo the iodoform test, okay? Look for the methyl, firstly. And you also have the case where sometimes they'll ask you if this compound undergoes the iodoform test, okay? And although it does contain this group that we do require for our iodoform test, we have to understand that it is a carboxylic acid, and it is a carbonyl compound, but it is not my aldehyde, it is not my ketone, which are the only carbonyl compounds that can undergo the iodoform test, right? So we do not include this as a positive for the iodoform test. Also, here's another interesting question. Let's take something like this, okay? Let's take CH3, C double bond O, CH2, CH2, CH3, and let's take CH3, CH2, C double bond O, CH2, and CH3, right? So this is 2-pentanone and this is 3-pentanone. Now, if you want to test to differentiate these, the best test and almost one of the only tests is called this year Haloform test, okay? So this tests positive with the haloform because it has this group, and this does not test positive because it doesn't have a methyl attached to the carbonyl group at all, right? So it's a great way to differentiate that.